So Priyanka asked me a question about adsorption isotherm. Who messaged me? Is it Priyanka? Freundlich and adsorption isotherm. Priyanka? Palak asked. Okay. So actually both are the same. But in the exam, if they ask you to draw that Freundlich isotherm, then the log x by m that you will draw for Freundlich. If they ask about what are adsorption isotherm, then you can say that the general definition, the plot drawn with x by m against p, where x by m is the amount of gas adsorbed per unit mass of the adsorbent. Is it clear now? Okay. So now we will start with the catalysis, the second topic. Okay. So catalysts, you know what are catalysts? These are substances. Sometimes the chemical reactions are very slow. So to increase the speed of the chemical reaction, we add another substance that is called catalyst, isn't it? So there are negative catalysts also. Sometimes we want the reaction to decrease the speed, reduce the speed. Then there are negative catalysts also. Mostly to increase the speed we add. And so in this topic, one more questions, whatever the names of the catalyst given for a particular reaction, those names you have to learn by heart. Okay, so one more questions they can ask. So, and see, you know that catalysts are highly specific. That means for a reaction, there is a particular catalyst. It is not that a catalyst can catalyze any reaction. Specificity, yesterday we learned, isn't it? Physis option and chemis option, physis option, lack of specificity you learned. So catalysts are also specific. So you have to learn the names of the catalyst in particular reaction. And oh, Arbas. Arbas, where were you all these days?
Actually, his number is not in the group, so I sent him the link.
Okay. Why his number is not in the Vishnupriya? Add him in the group, okay? Anyway, he has reached. Good. Now, Shashank and
Ma'am,
what Vishnupriya?
I keep adding him and he keeps leaving the group.
Oh,
That's why.
Arbas, are you there?
And at times I don't get to know.
Arbas, can you hear me? Arbas, why are you exiting from the group? Don't do that, okay? So we are doing the surface chemistry. You missed 3 classes. So surface chemistry we are doing, and in that the first topic is over and the second topic catalysis. So I was talking about catalysts. Catalysts are substances added to increase the rate of the reaction. And the first one example they have given, potassium chloride decomposes to give potassium chloride and oxygen. There manganese dioxide is the catalyst. So whatever the reactions given, the catalyst name you have to learn. All of you got it? Catalyst. And so the next terms, promoters and catalytic poisons. So sometimes they ask you, what are promoters? What, Prashant, what is the problem? Prashant is not getting the class link. Okay. So promoters are substances which enhances the activity of the catalyst. You have to write the term which increases the activity of a catalyst. Okay. So if you add this promoters, the activity of the catalyst will be increased. Haber's process. Can anybody say the catalyst?
Ma'am, can you repeat it?
The terms I am talking about, the terms in catalysis. The first term is promoter. Promoter is a substance which increases the activity of the catalyst. Got it? And for example,
Yes, ma'am.
Haber's process. You know Haber's process. You will manufacture ammonia, isn't it? By ammonia, there iron acts as the catalyst, and molybdenum acts as
Finally divided.
finely divided iron acts as the catalyst, and molybdenum is the promoter. So molybdenum is added to increase the activity of the catalyst. Clear? And so that is the first term. And the catalytic poison means sometimes we don't want the reaction to take place faster. So if they ask you, the catalytic poisons are substances which reduces the activity of the catalyst. Okay. Now the next term is, so in the book you underline. Agnel, you can take the textbook and underline. No need to write here. It is, or everything is given in the book. If it is not there, I will tell you. Okay.
Okay, ma'am.
So here Agnel take this homogeneous and heterogeneous catalysis. Homogeneous catalysis. Before that, promoters are substances that enhance the activity of the catalyst, and the poisons decrease the activity of the catalyst. Underline, okay? And then examples of each catalyst. First reaction, potassium chloride giving potassium chloride and oxygen. Manganese dioxide is the catalyst. Second, all of you just note it down in the book. The second one, the Haber's process. Iron is the catalyst and molybdenum is the promoter. Now the next one. Next term is homogeneous and heterogeneous catalysis. So here, this is also a board question. Homogeneous catalysis we say when the reactants and the catalysts are in the same phase. PHASE, same phase. When the reactants and the catalysts are in the same phase, it is homogeneous catalysis. When the reactants and the catalysts are in different phase, it is heterogeneous catalysis. So tell me Haber's process. Nitrogen gas plus hydrogen gas giving ammonium gas. The catalyst iron is a solid. So is it homogeneous or heterogeneous?
Heterogeneous, ma'am.
Isn't it? Because catalyst is in the solid phase and reactants are in the gaseous phase. So heterogeneous if the catalyst and the reactants are in different phase. Clear? So examples you underline. You see the book, textbook, homogeneous catalysis. See the first one, sulfur dioxide plus oxygen giving sulfur trioxide. This reaction is used for making sulfuric acid. Okay. So first, for making sulfuric acid, there are two processes. Contact process and lead chamber process. If you want, you can write. For making sulfuric acid, two processes are there. Contact process and lead chamber process. So the reaction is you will first convert SO2 to SO3, and SO3 will be absorbed in, or it takes water, and or you add oleum to it. So anyway, from SO3 by adding water you get sulfuric acid. Okay. So the reaction is SO2 plus O2 giving SO3, and you know that SO2 is a gas, O2 is a gas. If the catalyst is NO, nitric oxide, which is again a gas, then it is called lead chamber process. If the catalyst is NO, it is lead chamber process. So is it an example of homogeneous or heterogeneous?
Homogeneous.
Homogeneous. Very good. So lead chamber process is the first one given.
Homogeneous.
Okay. Homogeneous. And the same reaction, SO2 plus O2 giving SO3, you must have heard the vanadium pentoxide. Then it is contact process. Platinum or vanadium pentoxide is the catalyst, It is called contact process. Contact process. There, platinum or vanadium pentoxide, the catalyst is a solid. The reactants are gases. So it is an example of homogeneous catalysis. Clear? The third example given is esterification. Esterification in class 10 you learned, isn't it? Ester on hydrolysis. You will get the alcohol and carboxylic acid. You learned in 10th standard. And you did in the lab also, esterification, isn't it? The smell, the pleasant smelling ester. Remember esterification? So there the catalyst is acid, sulfuric acid. So esterification is alcohol reacts with the carboxylic acid. Oh, I said the opposite. Okay, alcohol reacts with the carboxylic acid in presence of a mineral acid, sulfuric acid, to give you ester. That is esterification, isn't it? Opposite only I said, that is hydrolysis. Clear, children? Esterification is formation of ester from carboxylic acid and alcohol. So carboxylic acid is a liquid, alcohol is a liquid, the catalyst, sulfuric acid, is a liquid. So that is an example of homogeneous catalysis. Clear? Understood?
Yes, ma'am.
Okay. Now
Ma'am, we can
heterogeneous.
use HCl also.
Can you?
Can we use HCl?
Yes, any mineral acid. So in
Okay.
our lab we use this sulfuric acid. You can use. Who is Nisha? Chinmaya? Okay. Okay. So that is homogeneous and heterogeneous catalysis. And they have given different examples. All the examples I told you, you should learn the example. Haber's process is given and Ostwald's process. Ostwald's process is the next one. Ostwald's process is, it is ammonia plus oxygen. Have you seen that? The third one, 4NH3 plus 5O2 giving 4NO plus water. So ammonia and oxygen are gases and the catalyst platinum, that is Ostwald's process for making nitric acid. This process is used for making nitric acid. It is an example of which heterogeneous catalysis. Hydrogenation of oil. The catalyst is nickel. You learned in 10th standard. That is also an example of heterogeneous catalysis. Clear, children? Any doubt on this? Any doubt you can ask? We'll go ahead. What happened, Anand? Why, Ostwald, why you are feeling like laughing? Who said Ostwald? Okay. Okay, children. So any doubt you can ask. Otherwise, we will move to the next. Okay. Okay, Prashant. Ostwald process is used for making nitric acid, like sulfuric acid, sulfur dioxide plus oxygen giving sulfur dioxide, isn't it? Similarly, for making nitric acid, in Ostwald's process, we take ammonia. Ammonia plus oxygen, you get a nitric oxide. From nitric oxide, you can make a nitric acid. Okay. So the catalyst is platinum. So ammonia and oxygen are gases. Platinum is a solid. So it is an example of heterogeneous catalysis. Is that okay? Okay, Prashant? Have you understood? Okay, so coming to the next one, this is a theory, adsorption theory. So before starting with that, let me explain. The adsorption theory given in your textbook is the modern adsorption theory. So earlier there were two theories, adsorption theory and intermediate compound formation theory. Okay, so the intermediate compound formation theory explains homogeneous catalysis and adsorption theory explains heterogeneous catalysis. Now the adsorption theory given in the book, that is the modern adsorption theory, is a combination of both. So first I will just tell you intermediate compound formation theory that explains homogeneous catalysis. So in that the catalyst is a solid and on the surface of the catalyst, on the surface of, first the catalyst will react with one of the reactants and form an intermediate compound.
This is which theory?
This is the theory, not completely explained in the book. So this they may not ask to make you understand I am saying. So they mentioned about this theory. Intermediate compound formation theory explains homogeneous catalysis. Okay. So the
Okay.
theory says the catalyst will react with one of the reactants. Suppose A plus B giving product and the catalyst is C. So the catalyst will react with A and AC will be formed. So the catalyst will react with one of the reactants and form an intermediate compound. That intermediate compound, here the intermediate compound is AC, that will react with B. So the intermediate compound will react with the other reactant, forming the product and releasing the catalyst. Okay, so you may be knowing the catalysts, they do not take part in chemical reaction. Do you know that? After the reaction, you will get to the catalyst as such. It will not take part in chemical reaction. So this theory explains that. According to this theory, intermediate compound formation theory, catalyst will react with one of the reactants, form an intermediate compound. That intermediate compound will react with the other reactant, forming the product, releasing the catalyst. Clear? Is it okay? Understood?
Ma'am, catalyst is C, right? It reacts with A, so how can it not take part in any chemical reaction?
No, that complex is formed. After that, it is just an intermediate complex, not a compound. Intermediate compound, it is for some time. It will form just a compound and that compound will decompose and a catalyst will be released.
Okay.
Okay. Okay. So just 1 minute. Okay, so that explains homogeneous catalysis. And heterogeneous catalysis, they are saying catalyst. It is a solid, and on the surface of the catalyst, the reactants will get adsorbed, adsorbed. So yesterday application of adsorption, heterogeneous catalysis was there, isn't it? So on the surface of the catalyst, the reactants will get adsorbed and product will be formed, and then once the product is formed, it will move away from the surface of the catalyst. That means opposite of adsorption will take place. That is desorption. So the theory given is a combination of both. And so this is an important theory. It is very easy. A diagram is given in the next page. You have to go through that also. You have to draw the diagram also. So there are different steps. The first step, catalyst will be there. There the reactants will diffusion of the reactants. Diffusion means it will go near the catalyst. And the second step is adsorption of the reactants on the catalyst surface. And the third step, once the reactants get adsorbed, intermediate compound will be formed. And once the next step is the intermediate compound will be formed, and then the product will be formed. Next step, the product will move away from the catalyst surface, that is desorption. Okay, and so desorption will take place, and the last step, it will go away, diffusion of the product away from the catalyst surface. Okay, so that is it.
Ma'am, I have a doubt in this.
Say.
If the reactants come and get attached on the catalyst, then they form bonds like chemisorption will take place, right? Then they slowly react with the catalyst, which will lead to the loss of the catalyst from the thing.
No.
Mass.
No. Here, this is catalyst intermediate compound will be formed, na?
Yes, ma'am.
Intermediate first activated complex will be formed. They are not with the catalyst, on the surface of the catalyst. It's a combination of both the theories. The product only, intermediate complex, you are confused with that intermediate compound formation theory, not that type of intermediate compound. Here in this case, first once it gets adsorbed and an activated complex will be formed, that is the product. It is the product only. You can see the diagram, next page. Adsorption of reactant molecules. Intermediate, they are saying, because it is on the catalyst surface, but it will be the product only. Don't get confused with that original theory. It is a combination of both. Okay. So if it is confusing, that original theory, they will not ask. They will ask you, they see the diagram. Catalyst surface is having free valencies. The reactant molecules will come. You see the diagram, next page. Adsorption of the reactant molecules. You saw that A and B got adsorbed. See, I will go to the board. Can you see the board?
Yes, ma'am.
Okay. So, this is the catalyst surface. These are the free valencies. So, first the reactants and the product will diffuse, come near it. Reactants and products. So, this is also there. So first they will get adsorbed. See, this is the free bonds. They will get adsorbed.
Ma'am, the lower part is not.
This is adsorption. Then the next step, complex. This is the intermediate complex. This will be formed. This is our compound. So intermediate complex is the product is AB only, not with the catalyst. Catalyst, these are all happening on the surface of the catalyst. Clear? And now this has to be removed, isn't it? Desorption will take place. That is the next step. Desorption means AB is the compound will come. And the last step, it has to diffuse out of the curve. From the near the catalyst area, it has to diffuse. Now clear?
Yes, ma'am. Clear, ma'am.
Okay. So,
Ma'am.
So, you will be drawing the diagram. Yes. Say.
Ma'am, recently what you said, could you tell again? My connection was disconnected just now.
I can't hear. Say once more.
Ma'am, just now whatever you said, could you repeat, because my connection was disconnected.
So
I joined just now again.
See, the theory you underline in the book. You will say, if they ask you, you will say 3, 4, 5. points. Out of that, you will say diffusion. The following steps, the mechanism involves 5 steps. You will say that 1. Diffusion of reactants to the surface of the catalyst. Second, adsorption of the reactant molecules on the surface of the catalyst. Third, occurrence of chemical reaction on the catalyst surface through the formation of an intermediate. And the fourth one, desorption of the reaction product from the catalyst surface. And the fifth one, diffusion of the products away from the catalyst surface. This much you will write and draw the diagram. Clear? Okay. So that is the important features. Next topic, the important features of the catalyst. Important features of the catalyst. First one, suppose they ask you, explain the features of the catalyst. This will be the question with respect to activity, with respect to selectivity. Like that they can ask you. Okay. The features or characteristics of the catalyst with respect to activity, with respect to selectivity. So selectivity, you know that they are highly selective. You agree? I already said one reaction will be catalyzed by only one catalyst. It is not that any catalyst can catalyze any reaction. No, they are highly specific. That point is clear? And they have given examples. Here also questions, 1 mark question can come. See, carbon monoxide plus hydrogen giving methane plus water. The catalyst used, nickel. You have to learn by heart. Carbon monoxide plus hydrogen giving methanol. The catalyst used is copper on zinc oxide and chromium oxide. So then again, carbon monoxide plus hydrogen giving formaldehyde, the catalyst is copper. Like that, they can ask for 1 mark. So each catalyst you will be learning. Clear? Understood? Selectivity, what is the point?
Ma'am, in the
Catalysts
second
are
example, it's given.
highly selective.
In the second example, it's
say
given copper on zinc oxide.
It is there in the book, Naomi. Textbook is with you,
yeah,
na?
but
Chromium oxide. It is there.
so
You just have
it
to
is upon
learn
both of them.
for 1 mark question. This reaction, which
Yes.
is the catalyst. Like that they can ask.
Yes, ma'am. So copper on both of them, zinc oxide and chromium.
And chromium oxide.
Okay. Yeah.
Okay. We'll go to the next selectivity feature. Can you explain again? Okay, selectivity means a particular reaction is catalyzed by only one catalyst. It is not that. In Haber's process, only iron can be the catalyst. So nowadays, different types of forms, the different catalysts are also there. But iron can catalyze, iron cannot catalyze, you can say contact process. No, it cannot catalyze. So one particular reaction, one catalyst. Clear, Prashant? Is that okay? Prashant, I am waiting for your response. Okay. Okay. So next point is activity. Here I am saying the point of activity. Here the activity means how fast it can catalyze the reaction. That is activity, isn't it? So for the catalyst, the activity means the reactant molecules should be strongly, it is reasonably strongly adsorbed on the catalyst surface. Reasonably strongly. Why I am saying reasonably strongly means if it is very strongly bound to the catalyst surface, then desorption will be difficult, isn't it? After the product formed, the product should dissolve or move away from the catalyst surface. If it is very strongly held to the catalyst surface, then desorption is difficult. And if it is very weakly held to the catalyst surface, then activity will be less. So, but the point is, the reactant molecules should be held to the catalyst surface reasonably strongly. Clear? So that is the point. It should not be very weak and it should not be very strong. Okay, so 2 points, activity and selectivity. Now the next topic is shape selective catalysts. Shape selective. So the question will be, these are all direct questions. They will ask you directly, what are shape selective catalysts? So shape selective catalyst, you have to say correctly the point. You have to learn. I will read out the catalytic reaction which depends on the pore structure of the catalyst. First point, catalytic reaction which depends on the pore structure of the catalyst and the size of the reactants and the product molecules. So all of you read 2-3 times. If they ask you about shape selective catalyst, the mark division will be that the catalytic reaction that depends on the pore structure of the catalyst, the pore structure of the catalyst and the size of the reactants and the product. So shape means the size of the reactants and the product. That is called the shape selective catalyst. Example, zeolite. Zeolite we learned somewhere. Zeolite used in petrochemical industry, isn't it? So zeolite is a shape selective catalyst. These are aluminosilicates. So three-dimensional network of aluminosilicates. So that you will learn. Zeolites are used in petrochemical industries for cracking of hydrocarbons and isomerization. Underline that. For cracking of pore structure, yes. You can, Prashant, you can refer the textbook if you are not able to understand my pronunciation clearly. You can take the textbook. Okay, so you go through the textbook, it is there. And so zeolites are used in petrochemical industries for cracking of hydrocarbons and isomerization. And an important one is ZSM5. Underline that one mark. ZSM5 is a zeolite which converts alcohols directly to petrol. So alcohol to petrol, we can get petrol from alcohol using this catalyst ZSM5.
Ma'am, what's the full form for
yes?
ZSM? Full form of ZSM?
Yes, Anand?
The full form, ma'am.
So clear this much? So the question
This is clear, ma'am.
Huh?
And this is clear, but what's the full form of ZSM?
It is a zeolite only. It is there are different types of zeolite catalysts. For this, we use ZSM5. Okay, this the different zeolite. This is a type which converts alcohol to petrol. So you get you can get petrol from alcohol also.
Okay.
Okay. In Agnel is asking in Ostwald's process, nitric acid, it is given in the textbook, ammonia plus oxygen, nitric oxide. So then you want to know how nitric acid is prepared. So in this, nitric oxide will be formed. Nitric oxide will be converted to nitrogen dioxide by oxidation, and a nitrogen dioxide with water, nitric acid you will get. That is how you get. Okay. So okay. Any doubt? Any other doubt you can ask now? So after adsorption theory, I told you the questions. The questions explain the features of catalyst. Like that they can ask, then selectivity and activity you will say. Sometimes 1 mark question with respect to activity, with respect to selectivity. Like that they may ask. Next question is shape selective catalysts. There many 1 mark questions are there. Zeolites, ZSM5, Okay. Now, any doubt? Enzyme catalysis, that is also an important topic, enzyme catalysis. We'll go ahead with enzyme catalysis. So, bio children, tell me what are enzymes? Varshini? Varshini, Isha, Varsha, what are enzymes?
Complex
Ma'am, they are
substances.
proteins.
Jay is there. Very good, Jay. Say.
And they are the complex compounds which increase the rate of the reaction by thousands or millions.
Can't hear. Little more louder.
Increase the rate of the reaction. That's all.
What are enzymes?
They increase the rate of the
Ma'am,
reaction.
Say, Isha.
Mom, they're substances that increase the rate of the reaction.
I can't hear. Hey, can you hear me clearly? What you are saying only I am able to hear.
Ma'am, enzymes are biochemical catalysts which lower the activation energy of a reaction.
No, you don't have to read and tell me. Whatever you know, you tell. Okay, I will only say what said is correct. They are biochemical catalysts. In our body, so many reactions are taking place, isn't it? So enzymes are the catalysts. That is why they say, if somebody asks you, the first point, they are biochemical catalysts. Okay? And next point, chemically, we are learning not in bio, isn't it? We are chemically, they are proteins. You know what are proteins? Anyway, next book you will be learning in detail. So they are proteins and they are biochemical catalysts. Okay, and proteins, you know that these are macromolecules. You agree? Proteins are very big molecules and they are polymers of amino acids. So that is why somebody said, they are complex molecules. They are protein molecules for time being. They are, our topic is catalysis, isn't it? They are biochemical catalysts and they only catalyze the reactions taking place in living organisms. Okay, and so that is enzyme. Enzymes are catalysts. So that is why enzymes are coming in our topic. And here also questions. So there are many reactions are given here, and they will ask you 1 mark the name of the catalyst. Tomorrow I will be asking the names of the catalysts. So children, learn, and I will be asking, and you know that without seeing the book, it is just to help you out. If you hear this and go means it is of no use. You have to learn, isn't it? And I know that today I asked, some children answered very fast. So they are the children who learned and came. Some children are searching the book. I can make out. So I know you are my children. 1 year I taught you. I know every one of you. So all of you learn, come questions I will ask. Okay. So the names of the catalyst here. In the book you underline the names, only the names of the catalyst. You learn, I will be asking tomorrow. The first one is conversion of cane sugar to glucose and fructose. Question will be like that only. Which enzyme is used for converting the cane sugar to glucose and fructose? So conversion of cane sugar to glucose and fructose, invertase. Next one. Conversion of glucose to ethanol, zymase. Third one, conversion of starch to maltose, diastase. Bio children must be knowing some of the examples. And next one, maltose to glucose, maltase. Some are easy. Maltose to glucose, maltase. Similarly, urea to ammonia, urease. Got it? And the sixth one is very, very, very important board question. In stomach, pepsin converts proteins to peptides. So pepsin converts, you can remember PPP. Pepsin converts proteins to. So here, sixth point, 2 enzymes, pepsin and trypsin. So pepsin converts proteins to peptides. The second one, trypsin converts proteins to amino acids. Got it? Then the seventh one, conversion of milk into curd. So that is done by lactobacilli enzyme. present in curd. Now, I'll give you 1 minute to learn this by heart, children. Name of the catalyst. Quick question I will ask you. Learn now, all of you. Then we will go to the next topic. Okay, 1 minute I will give. Go through that and learn. Learned? Okay. So Amitav learned very good. So which enzyme converts proteins to peptides?
Ma'am, it is pepsin.
Amitav, don't see the book. Just say.
Pepsin,
I said in a PPP. Protein to peptides?
Pepsin. Ma'am, it's pepsin, ma'am.
Pepsin. So Abhishek, proteins to amino acid, which enzyme? Abhishek left. Whenever question comes, you leave. Huh?
Ma'am, I have a doubt.
Isha.
Yes, ma'am.
Okay, Isha, which enzyme proteins to amino acid?
Trypsin. Trypsin. Ma'am, can you hear me? Trypsin.
Why so much time you took?
No, I was telling from.
Fast, you are a smart girl, na? Fast you should say. Okay. Bharati, are you there? Bharati?
Yes, ma'am.
Okay. You tell me glucose to ethanol, which enzyme?
Glucose to
Zymase. Good. So you go through that and learn. Some children already learned very good. And so the next topic, characteristics of enzyme catalysis. Again, very important. Characteristics of enzyme catalysis. One is common one. You can say that selectivity. Catalyst is selective. So the second point, they are highly specific, isn't it? So specificity is the first one, and they are highly specific. And Prashant, you read that sentence. One catalyst cannot catalyze more than one reaction. That is specificity. Okay? And highly efficient. Enzymes are highly efficient. They have here they said one molecule can transform 1 million molecules. Characteristics. You can straight away go refer the textbook. So they are highly efficient. They are highly specific. Next point, they are highly active. They are highly active under optimum temperature. So at one particular temperature, the range is given 298 to 310 Kelvin. So that is coming to our human temperature. That is why they are highly active under optimum temperature. So the optimum temperature is 298 to 310 Kelvin. Clear? Similarly, there is optimum pH also. Optimum pH is 5 to 7. So this, and next point, there are certain, see, coenzymes and activators. Coenzymes and activators, they increase the activity of the enzymes. Okay, coenzymes and what are coenzymes? What are activators? So like that, they will ask you questions. Okay. So the reading, enzyme activity is increased in presence of certain substances. Underline that enzyme activity is increased in presence of certain substances called coenzymes. Example, they are non-protein molecules. Enzymes are proteins, I told you. But then this coenzymes are not proteins. Example, vitamins. Got it? Coenzymes. They are substances which increases the activity of a catalyst. Underline that. They are non-protein molecules. Example, vitamins. This much you have to write. Now, activators. Activators are metal ions like Na+, Mn2+, and Cu2+. These metal ions will increase the activity of the catalyst. They are activators. So, very important, activators and coenzymes. And inhibitors and poisons. So here also there are inhibitors or poisons which will reduce the activity of the catalyst. So sometimes in the body we don't want a particular reaction to take place. So then we want to reduce that activity of the catalyst, then we take drugs. Those drugs will act as poisons, catalytic poisons, so that that reaction will not take place. Got it? Reactions you cannot do, you don't, Amitav, reactions you don't have to learn, but you should know that they will ask you the name of the reaction. Okay. So, Agnel is asking which is used in Ostwald's nitric oxide. Nitric oxide is formed. Platinum is the catalyst. It is there in the book. Okay. And they will ask you the name of the reaction and the catalyst. That is it, Amitav. Okay. See, how many of you are not able to hear me? Just to tell me. If you are able to hear, just say yes. Hear me properly. Any problem with the class?
Yes, ma'am.
Because some are saying, how many of you can hear me properly? Just to say yes. Because some are saying network issues.
Yes, ma'am.
Anand, you
Yes,
can
ma'am.
hear, and I can also clearly hear Anand, Amitav and all clearly. I can, Vishnu Priya, these children, I can clearly.
Yes, ma'am.
So most of you are able to hear me. Only some have problems, isn't it? Arbaz, you have to attend the classes and daily now, okay? Today, Ajay was absent and Ajay only is absent. Shashank is absent, I have to see. I will be sending each day attendance. Okay, so that is about the characteristic of enzymes. Next one, mechanism of enzyme catalysis. Again important, mechanism of enzyme catalysis. And here it is like, I will just say, it is very clearly explained in the book. Mechanism is that the surface of the enzymes, here the catalyst is the enzyme, isn't it? Surface of the enzyme has cavities of a particular shape. And these cavities contain active groups like NH2, COOH, SHOH. So active groups will be there. So that each catalyst is having a cavity of a particular shape also a particular shape. And these cavities contain active groups. So the reactant molecules having complementary shape, I said the cavity is having a particular shape. So the reactant molecules having complementary shape will come and fit into the cavities and the reaction will take place. Like key and lock. See, you cannot open the lock with any key, isn't it? So like that. That is why they are highly specific. Clear? The cavities of a particular shape, the enzyme surface. The enzyme is the catalyst and it is having cavities of a particular shape. That is point 1. Point 2, these cavities contain active groups like NH2, COOH, SH and OH. And so the reactant molecules, third point, reactant molecules having complementary shape will come and get locked into the cavities and a reaction will take place. Clear? So the mechanism you can underline. See, there are a number of cavities present on the surface of the enzymes. And these cavities are of characteristic shape and possess active groups like NH2, COH, SH, OH, etc. These are
This explains selectivity, right?
who is this?
Anantma.
Selectivity.
Yeah, like it should have a proper shape. That's when it will like
Yes,
react.
yes. That explains the selectivity of the catalyst, because suppose the catalyst is having a cavity of a particular shape, like the key and lock, the reactant molecules should have complementary shape. It should fit into that. Okay.
Okay.
This puzzles you make, that what is that called?
Jigsaw puzzle.
Like that only. It is like a key and lock. So that is why they are specific. So any reactants cannot come, and the reactants having complementary shape only will come. Okay.
Okay, ma'am.
Clear?
Yes, ma'am. Clear, ma'am.
Okay. So that is it. It is very clearly explained. The molecule. Yes.
Ma'am, here the cavities are the catalyst.
Yes, cavities.
Are they the catalyst here?
I can't hear. Priyanka.
Are the cavities the catalyst, ma'am?
Catalyst is the enzyme. Enzyme is having a cavity of a particular shape. So the reactant molecules having complementary shape will come. Like a key and lock. You cannot open the lock with any key. So the complementary shape is required. That explains the selectivity. Clear? So you have to say this sentence. The molecules of the reactants which have complementary shape fit into these cavities. Just a key fits into lock. On account of the presence of active groups, activated complex. I told you, the first point. They have active groups and an activated complex is formed which decomposes to give the product. Clear? That is the mechanism. And see, once last year, they asked the mechanism of enzyme catalysis. There you have to write step 1 and 2. Have you seen that? The mark you have to say, write step 1 and 2. Binding of enzyme to the substrate to form activated complex, E plus S, ES, activated complex. That decomposes, E plus P. This you should write. In the case of enzyme, this is the mechanism. Activated complex will be formed that will decompose to give the enzyme and the product. Okay, so E plus S, ES. ES will decompose and you will get the, where E is the enzyme, S is the reactant, and ES is the activated complex that decomposes to give E plus P. Diagram is not required, Navami. So it is like you will say that, here when this question came, in the key they said the mark will be there for step 1 and step 2. Okay. So that is enzyme catalysis. We are about to finish this. And see, another table is given. You have to learn the table. And the name of the catalyst. Here, Agnel, Ostwald's process. You see that Ostwald's process, nitric acid, you don't have to learn the reactions and all. The catalyst name, platinized asbestos. Contact process, platinized asbestos or vanadium pentoxide. That much you have to learn. So that is about catalysis. Any doubt? You have to learn all the names of the catalyst. Yes.
What happens to the enzyme after the catalysis reaction, ma'am?
Enzyme is a catalyst. It will be, nothing will happen. After the reaction, you will get the enzyme as such.
Okay, ma'am.
The catalyst will not be used. An activated complex will be formed. That will decompose. Enzyme, nothing will happen. You will get the same amount of enzymes and chemically nothing will happen. All the catalysts, it will happen.
That enzyme can again go and form an activated compound with something else.
Activated, that is just an intermediate. That will decompose and you get the enzyme, intermediate activated complex only, not a proper chemical compound.
Okay, ma'am.
Okay.
Fine, ma'am.
So, any doubt in that? And in-text questions, children? In-text, in absorption, any in-text question, characteristics? Okay, in-text questions we will discuss. Page 127, characteristics of chemisorption. Those are direct questions. Why does physisorption decrease with increase in temperature? Direct question. Why are powdered substance more effective adsorbents? Why powdered substance? Because
Surface area increases.
surface area is
area
increased.
with increase in surface,
Increase the surface area.
surface area.
Okay. Now the next index question here, catalyst. 5.4, all of you take page number 133. 5.4. In Haber's process, hydrogen is obtained by reacting methane with steam in presence of nickel oxide. This is known as steam reforming. See, Haber's process, hydrogen is there, nitrogen and hydrogen, isn't it? So hydrogen is produced by this process. And why is it necessary to remove carbon monoxide? You understood the question. Haber's process is manufacture of ammonia from nitrogen and hydrogen. Okay. So when hydrogen is produced, so by steam
Carbon
reforming,
monoxide acts as a catalyst poison.
so the why we remove, because carbon monoxide acts as a catalytic poison. Right there. Why we remove? Because carbon monoxide acts as a catalytic poison. Clear? Now, why is ester hydrolysis slow in the beginning and becomes faster after some time? Can anybody tell me? Ester hydrolysis. What is ester hydrolysis? Ester on hydrolysis gives you.
So,
What is ester hydrolysis?
Ethanoic acid and alcohol.
Very good. Ethanoic acid and water, carboxylic acid and alcohol, isn't it? They are saying in the beginning the reaction is slow. Later the reaction becomes faster. Why? Because the carboxylic acid is formed, isn't it? That will catalyze. That is called autocatalyst. AUTO. Automatically it is catalyzed, isn't it? So you write the carboxylic acid formed acts as autocatalyst. The carboxylic acid formed will catalyze the reaction automatically. So you don't have to add any catalyst. So that is why. Clear? What is the role of desorption? If desorption is not happening, the catalytic surface will not be free, isn't it? So for further reaction, the desorption will help in making the catalytic surface free. Clear? Exercise questions. Come to exercise, children. Exercise, all these questions are direct questions except one. One question is here, I will say. Absorption body. 5.6. All of you take a 5.6. 5.6, since the question is in the textbook and answer is not given, I will give you the answer. 5.6. What do you understand by activation of adsorbent? How is it achieved? Got the question? 5.6.
Yes, ma'am.
What do you understand by activation of the adsorbent? So write the answer. You can write there, activation of the adsorbent. It is increasing the adsorbing power of an adsorbent, right? Activation is increasing the absorbing power. Increasing the absorbing power of the adsorbent. Written? increasing the adsorbing power of the adsorbent. Increasing the adsorbing power of the adsorbent. This can be done. This can be done by increasing the surface area. This can be done by increasing the surface area of the adsorbent. Okay? This can be done by increasing the surface area of the adsorbent. Okay, catalysis are done. Now the next topic is colloids. Any doubt you can ask? Go through that. Any doubt? Okay, children. We'll go to colloids. Okay, so tell me any doubt? Children, any doubt? Why nobody is here?
No, ma'am.
No, ma'am.
We'll go to colloids.
Yes, ma'am.
Yes, ma'am.
Why others are not? Any
Yes,
doubt
ma'am.
in this? We'll go to the next topic, colloids. What are colloids, children? Have you heard about anybody? Can anybody tell me? What do you know about colloids? Okay, colloids. What are colloids, children? Any idea?
Ma'am, they appear to be homogeneous, but they're actually, but their composition is heterogeneous, ma'am. Hello? Ma'am, I'm audible. Ma'am, they appear to be homogeneous, but their composition is actually heterogeneous.
Heterogeneous.
But their appearance is somewhat homogeneous.
No, I can't hear. Okay, I will only say. See, the solution. All of you know what are solutions? So, solutions can be
Yes, ma'am.
classified into three based on the size of the particles. What are solutions? Solute will be dissolved in a solvent, isn't it? So, the particles means based on the size of the particles, you can classify the solutions into three. One, true solution. Second, colloidal solution. And the third one, suspension. I will give example of a solution and true solution and suspension. So here the classification is based on the size of the particles. Particle means solute particles. Suppose I take some salt and dissolve in water. I get a true solution where the size of the particles are very, very small. Or sugar dissolved in water, that is a true solution. After dissolving, you cannot see the salt or sugar in water, isn't it? The size of the particle is very small. That is an example of true solution. Suspension. Suppose I take sand and put it into a bucket of water. Can you see the sand particles?
Yes, ma'am.
Yes. So why we can see? Because the size of the sand particle is very large, isn't it? So suspension, the size of the particle is large. In true solution, the size of the particle is small, and colloids have the size in between a true solution and a suspension. Now got some idea? And the size of the particle in colloids are from the range. It ranges from
Ma'am,
1
can you repeat the point,
nanometer
ma'am?
to 1000 nanometer. So you can
Ma'am, can you
imagine the
repeat the
size.
point?
1 nanometer is 10 to the power minus 9 meter. That is very small, isn't it? But it is larger than the particles of true solution. Got it? So here the one main important thing you should remember in the case of colloid is the size of the colloidal particles should be within the range 1 nanometer to 1000 nanometer. Ask. What is the doubt?
I was asking the range.
Any doubt?
I was asking the range of colloidal.
Okay, so the size of the particle, that is. So you understood what is a colloid. Second point is, like Ruchi said, it is a heterogeneous system. Colloids are heterogeneous. And there will be two phases, PHASC, phases. Okay, and one is a dispersed phase, which are dispersed. Dispersed means that will be scattered in a continuous medium called dispersion medium. So two phases are there, and the dispersed phase that will be fine particles, and which are of colloidal range. They will be dispersed or scattered in a continuous medium called dispersion medium. You can say like a solvent. You understood that point? So the definition, like Ruchi said, it comes as colloid. There is a definition in the book. Take the textbook. A colloid is a heterogeneous system in which one substance, that is dispersed phase, has very fine particles in another substance. One substance is dispersed as a very fine particle in another substance called dispersion medium. Have you understood this definition? So in a colloid, there will be two phases, dispersed phase and dispersion medium. So the dispersed phase, they will be scattered or dispersed as fine particles in the dispersion medium. Clear?
Ma'am?
Yes, ma'am.
Yes.
Ma'am, so they appear
Clear,
to
children?
be...
Say, ask, I can't hear, Ruchi.
Ma'am, so they appear to be homogeneous, right?
Loudly, ask loudly.
Colloids appear to be homogeneous
Or you chat,
mixture.
I am not able to hear you. Chat, okay, I will see what you want to say. Children, you can now, since I am sitting, I can see. You can write also. I can see since. You can ask, write and ask the doubt. Ruchi, I could not hear you. They appear homogeneous. No. It will be dispersed. Na? So, like there are different types. You can say fog, mist, smoke. These are all colloids. Okay, we are coming to that. Examples are coming, Chinmaya. So, Prashant wants one more time. Okay, so colloids means one point is the size of the particle. You understood that? Size of the particle will be in between that of a true solution and a suspension. The second one, there will be two phases. So, the dispersed phase and a dispersion medium. And whereas the dispersion medium, milk is a colloid. Ruchi? That is liquid in liquid. Both the dispersed phase and the dispersion medium both are liquid. I will explain that, the types of colloids when you learn. Okay. So, Chinmaya, examples, the next table you have to, so many examples are there, table you have to learn by heart. 1 mark question you can expect from the table. So, coming to Prashant's doubt. So, this is where dispersed phase will be scattered in a dispersion medium. They will be scattered. They will not be dissolved. They will not be settled under gravity. So, they will be scattered. Okay. So, now coming to the, that is, Prashant, is it clear now? Now there is a table. All of you will learn by heart that table. Okay. 1 mark questions can come. Okay. So the table is saying Chinmaya's question. The examples. Okay. Here you can, the important wise I will say, the emulsion, liquid. See, the first part is dispersed phase, second dispersion medium, type of colloids, example. Like Ruji asked, liquid and liquid, both dispersed phase and dispersion medium are liquid, then it is an emulsion. That is the most important. Example, you have to learn the example also, milk and hair cream. The next important is fog mist. Here the fog, this is a fog is which type of a colloid? Mist is which? Mist, cloud, these are aerosol. The name of the colloid also you have to learn. And liquid in gas. Liquid is the dispersed phase, gas is the dispersion medium. That is very, very important. Next important one is cheese, butter, jelly. They are gel. The type of the colloid is gel. And dispersed phase is liquid. Dispersion medium is solid. 3 learn by heart now. Liquid in liquid, emulsion, milk and hair cream. Learn all of you. Then next one is liquid in gas, aerosol, and example fog, mist, cloud, insecticide sprays. Third one, liquid in solid, gel, cheese, butter. What? You have to learn by heart. Okay. And the question once they asked, give an example of a gel. So then that way they can ask. Or another type of asking, what are the dispersed phase and dispersion medium in cheese? So you should know all the 3 points. Name also, the example also, dispersed phase and dispersion medium. Then another one is paint. Paint is also a colloid. That is sol, SOL, solid in liquid. So next one is foam, FOAM, gas in liquid. So froth, whipped cream, soap lather. So like that the question comes. So important wise you will learn the table by heart. Tomorrow this table, catalyst, all that I will be asking. So this much clear, children? That table is very important. You know that 21 mark questions are there. So 1 possible question from that table. Types of colloids.
Ma'am, what is this emulsion paint? Emulsion paint, they say, right?
Emulsion paint.
Yeah.
So that is a type of paint, no? So
but paints and emulsions are like different, right? Paints
different.
are solid and
They are different.
then
So,
why emulsion paint?
Emulsion paint may be that, see, it is paint is solid dispersed in liquid. Maybe that solid part, I don't know about paint that in detail. That is a type of, they modify the paints. No? Maybe the liquid part, maybe, I don't know. Maybe semi-solid. Emulsion is liquid in liquid. Emulsion, a paint is not an emulsion.
Okay.
That is a modified form of paint like that you. Okay.
Okay.
So this much is clear. Any doubt you can ask? Types of colloids, classification of colloids. That is very, very important. Next topic. Classification of colloids. So there are 3 classification. 1 classification already we learned classification based on the dispersed phase and dispersion medium, isn't it? That is the first one. With the table is that only. Classification based on the dispersed phase and dispersion medium. You agree with me? That is the table. Yes or no? Children?
Yes,
Could
ma'am.
you explain that once more?
See, the topic is classification of colloids. Okay? And there are 3 types of classification. The first classification is based on the dispersed phase and dispersion medium. So that is what we learned, the classification: solid sol, sol, aerosol, gel, emulsion, solid sol form. These are all based on the dispersed phase and dispersion medium. Clear, Vishnupriya?
Yes, ma'am.
Is it clear?
Yes, ma'am.
So the second classification is based on the interaction between the dispersed phase and dispersion medium, the type of interaction. The first one, just the dispersed phase and dispersion medium. It changes and you will get the different types. Second one is the interaction between the dispersed phase and dispersion medium. Okay. And the third one is based on the type of the particles of the dispersed phase. Okay, type of the particles of only the dispersed phase. So 3 types of classification. One is based on the dispersed phase and dispersion medium, which we saw in the table. Second one is based on the interaction between the dispersed phase and dispersion medium. And third one is based on the particles of the dispersed phase. This is very important. Colloid is a very important topic. And so, first one over, second one, based on the interaction between the dispersed phase and the dispersion medium. So, they are classified into 2 types. If the dispersion medium, dispersed phase, has very much affinity towards the dispersion medium. What do you mean by affinity? If it is liking. Okay, if the dispersed phase has very much affinity towards the dispersion medium, it is lyophilic, L-Y-O-P-H-I-L-I-C. Philic means loving, isn't it? Hydrophilic. Hydrophobic means hating. So, lyophilic colloids and lyophobic colloids. Clear? So, first, lyophilic. Philic means both are liking each other. So, if the dispersed phase has much affinity towards the dispersion medium, it is lyophilic colloids. And if the dispersed phase has very little affinity towards the dispersion medium, it is lyophobic. Is it clear? Yes?
Yes, ma'am.
So now coming to here again questions. Again questions. Why Prashant not understood? See, philic word is loving, liking. Phobia, phobic means hating. Why my voice is not clear? So if the dispersed phase has much affinity or it is liking the dispersion medium, it is lyophilic. If it is not having much affinity, it is lyophobic. Now coming again to lyophilic. Lyophilic colloids. Lyophilic colloids, they see since both are liking each other, if you put the dispersed phase to the dispersion medium, simply mixing, you will get the colloid. Isn't it? So it is very easy to make. You can just mix the dispersed phase in dispersion medium, you will get the colloid. And so that is easily you can prepare by mixing. First point. The second point is, suppose the dispersion medium is separated from the dispersed phase. Suppose say by evaporation. Medium is gone. The dispersed phase is separated from the dispersion medium. Then you can just add some dispersion medium. Then again you will get a colloid. That means lyophilic colloids are reversible. That is very important. Lyophilic colloids are reversible. Got the point? Lyophilic colloids are...
Ma'am, can you explain that once again?
See, suppose the dispersion medium is separated from the dispersed phase in a lyophilic colloid. You can add a little more dispersion medium, you will get back the colloid. So it is reversible. Understood now? Got it?
Yes,
now?
ma'am.
Okay. So Chinmaya, one question. Lyophobic, there will be emulsion. See, lyophobic, I will give you examples. All the colloids are not lyophobic. Lyophobic examples are metals and their sulfides. Colloidal solution of metals and their sulfides. So emulsion point is not coming. Okay, Chinmaya? Okay. Okay, so lyophilic colloids, I will read. You have to, very important, you underline. Lyophilic colloids, the board question also, last year they asked. The word lyophilic means liquid loving. The colloidal salts directly formed by mixing substances like gum, gelatin, starch, rubber, etc. with a suitable liquid, they are lyophilic salts, underline that. And important characteristic is that if dispersion medium is separated from the dispersed phase, the salt can be reconstituted by simply remixing with the dispersion medium. So they are reversible salts. Understood? You have to underline and learn this much. And now coming to lyophobic. Lyophobic, you cannot just mix because they don't like each other. So special methods are required for preparation of lyophobic salts. Okay? And again, once you prepare and the dispersed phase is separated, you cannot just add. So they are irreversible. So these are the, and example, metals and their sulfides, they are examples of lyophobic salts. Okay? So here, lyophobic means liquid hating. Substances like metals and their sulfides, when simply mixed with a dispersion medium, do not form colloidal salts. Their salts can be prepared by special methods. And next point, they are irreversible. And again, one more point. So when you prepare lyophobic colloids, a stabilizing agent is required. So second classification clear? Is that clear, children?
Yes, ma'am.
Yes, ma'am.
Now the third classification. Here, can Vishnupriya tell me first what is the third classification is based on the nature of the dispersed phase. So the dispersed phase will be different in this classification. Okay, this is very, very important. And so when you learn also the same sentence you have to learn, which I tell you first, I will explain. Here, the classification is based on the dispersed phase, nature of the dispersed phase. So, the first one is multimolecular colloids. Multimolecular, from the name itself, there will be, see, you know that the colloids, there should be, the particle size should be of the order 1 nanometer to 1000 nanometer. Multimolecular, very, very small atoms or molecules, they are not of the range of colloidal colloidal range. So a large number of atoms or small molecules, they come, aggregate together, and then to form particles of colloidal range. Understood? That is why multi means a large number of particles aggregate together to form colloids. And how they aggregate together? They aggregate together so that the particle size, the range is reached. Got it? So example, sulfur and colloidal gold. These are examples of multimolecular colloids. If you understood, I will read the sentence. I will tell you what to learn. Have you understood? So here the difference is based on the nature of the colloids, the nature of the dispersed phase. Okay, nature of the dispersed phase. Have you understood this?
Yes,
And little bit of learning by heart is required. This is chapter is easy, but then correctly. Easy chapters, you have to use the correct terms. So I will read out what the same sentence I want you to write. On dissolution, a large number of atoms or smaller molecules of a substance aggregate together to form species having size in the colloidal range. Have you understood that sentence? Yes or no?
Yes, ma'am.
Yes, ma'am.
So that sentence as such I want. On dissolution, on dissolution, a large number of atoms or smaller molecules of a substance, so that is the dispersed phase, aggregate together to form species having a size in the colloidal range. Got it? Then example, sulfur, sol and gold. They are examples of multimolecular colloids. Okay. Now, macromolecular colloids. Can you guess what is this? Macro means very large molecules, isn't it? So the size will not be of colloidal range. So what happens? Such molecules like proteins and all polymers, isn't it? So example, starch, cellulose, proteins, you know they are polymers, a large big molecules. They, when dissolved in suitable solvent, their size will come in the colloidal range. Then they are macromolecular colloids. Understood? Got it? So from the name itself, you can guess and write. Then read that sentence 3-4 times, you will get the sentence. Is it clear? I will read what you have to. I want the same sentence. Macromolecules, macro means very large molecules. So when this happens in suitable solvent, so the sentence, macromolecules in suitable solvent form solutions in which size of the macromolecule may be in the colloidal range. That sentence as such I want. Clear? Is it clear, children?
Yes, ma'am.
Yes, ma'am.
So then example, that sentence and example. Example, starch, cellulose, proteins and enzymes. And again, polythene, nylon, polystyrene, synthetic rubber. Why the examples are, you should know that sometimes they ask you, synthetic rubbers are which type of colloid. Okay, so the examples are also required. Now the last type of colloids, associated colloids. Associated colloids, micelles, you learned in soap and detergent. That is, and a soap. Soap is an example of associated colloid. Okay, that also I will explain and then we will stop. So associated colloids, some substances at a low concentration they behave as strong electrolytes. Underline and learn. Low concentration behave as strong electrolytes, and high concentration they behave as colloidal particles. So the dispersed phase, low concentration, no colloids. High concentration, they behave as colloids. They are associated colloids. And associated from the word itself, micelle, you remember you learned in 10th standard. A number of molecules will be associated, micelle formation, isn't it? So the sentence is that there are some substances at low concentration behave as normal strong electrolytes. At high concentration exhibit colloidal behavior due to the formation of aggregates. These aggregates particles are micelles and they are called associated colloids. Any doubt you ask on this? Just to read that sentence and ask any doubt. Have you understood? Have you understood, children?
Yes,
so
ma'am.
that is the sentence you will say. And the mechanism of soap micelle formation you learned in I will just explain. Soap that you learned in 10th standard, the same thing. Soaps are sodium or potassium salt of long chain carboxylic acid. You learned that, isn't it? Soap is having one hydrophilic end, which is the ionic end, and a hydrophobic, the tail part. And then the mechanism same you learned in 10th standard. The soap will form a micelle around the dirt, isn't it? And so it will pull the dirt. The mechanism you learned in 10th standard, the same thing only. And but here is the two more points. And we said that at a particular concentration, at a high concentration only, they will form colloids. And this colloidal formation, micelle formation will take place above a particular concentration called critical micelle concentration, CMC, and above a particular temperature called Kraft temperature. Okay, so that is about the associated colloids. Is it clear? So this micelle formation, that is associated colloids, it will take place only above a particular concentration called CMC and above a particular temperature called Kraft temperature. That much? Any doubt? The types I will be asking questions tomorrow. Please learn and come. And smartly, like today some children answered. Some were searching in the book, not like that. I want the smart answers. Okay, any doubt you can ask? Any doubt, children? Abhishek left itself. So we will wind up for today. Tomorrow also same time. Okay, children? Anything, please explain associated colloids. Chinmaya. Associated colloids, they are, example is soap. So these some substances, when particular concentration is reached, they form micelles. Okay, so at a low concentration they are not colloids. At a particular concentration they form associated, means you micelle formation, it will aggregate together, isn't it? So that is associated colloids. Understood? Chinmaya, any other question? Okay. Projects, okay. Chinmaya, any children, any other questions? Anand? Okay, then we will wind up. Amitav, macromolecular
No doubts, ma'am.
colloids. Amitav is there? Amitav? Left? Ma'am, macro, yes. Okay, Amitav, macromolecular colloids means very large molecules. Here the dispersed phase only different, isn't it? Like proteins, they are all polymers, very large molecules. When dissolved in a suitable solvent, form solutions. In that, the particle size will be in the colloidal range. That is, okay? Okay, Amitav? Okay, then we will wind up tomorrow same time, and please come on time. Okay.
Ma'am, can you hear me?
Same time. If or every day same time. If any change, I will inform you.
Thank you, ma'am.
Ma'am, can you hear me?
Okay. Okay, children. Bye for today.
Ma'am, can you hear me?
No, it's recorded. Okay. I haven't stopped recording. Why?